Good afternoon, friends. I am Professor S.S. Jadhav. Today we discuss next point, that is thermal boundary layer. In last lecture we discussed about hydrodynamic boundary layer, and today we discuss about the thermal boundary layer. So for that we have to considering the case, that is Ts is greater than Ta. So what is meant by Ts? So for that we have to consider one diagram. So this is the diagram related to the thermal boundary layer. So in this diagram, so this is the flat plate, and having temperature is Ts, and fluid is flowing. This is the fluid is flowing having velocity capital U, that is free stream velocity, that is capital U, and temperature of that particular fluid, that is nothing but Ta. So in this case we have to considering the temperature of this surface is higher as compared to the temperature of this fluid. So in last lecture we discussed about the hydrodynamic boundary layer. In that we discussed about the flow over the plate of that fluid. So how to change the velocity of that particular fluid, we discussed about that. In this case now we have to considering the factor, that is temperature. So when the fluid is flowing through or flowing over this plate, and we have to considering the factor, that factor is nothing but temperature. So what is the effect of the temperature on this temperature of the surface to the fluid? So what way the temperature changes takes place? Means what? We have to considering the one plate, and on that plate we have to passing the fluid, and the temperature of that fluid is less as compared to this plate. Means what? Ts is greater than Ta. Means the temperature of this flat plate is higher as compared to the fluid temperature. So what is meant by thermal boundary layer thickness? So we have to consider one layer of the fluid. So that layer, so suppose consider this is the one layer, and that layer will touches this surface. So what will happen? So the temperature of surface is higher, and temperature of this layer will be lower, and this layer will in contact with this surface. Because of that, what will happen? Maximum heat transfer takes place to that adjacent layer. So temperature at this layer is higher. And when we moving in the upward direction, what will happen? The temperature of the each layer will be reduces. So from this, what is meant by thermal boundary layer thickness? Thermal boundary layer thickness is denoted by delta Th. So what is meant by this distance? This distance is nothing but thermal boundary layer thickness. So how to calculate that thermal boundary layer thickness? So thermal boundary layer thickness is defined as the distance y. So we have to considering the two coordinates, that is this is the x coordinate, this direction is nothing but x direction, and this upward direction, that is nothing but y direction. So what is meant by thermal boundary layer thickness is defined as the distance y from the plate surface. So distance y from the plate surface at which what is the condition? At which T minus Ts is equal to 0.99 into bracket Ts minus Ta. So if this condition is satisfied, and that distance is nothing but thermal boundary layer thickness. What is meant by thermal boundary layer thickness? The thermal boundary layer thickness is defined as the distance y from the plate surface at which y from the plate surface at which T minus Ts is equal to 0.99 into bracket Ts minus Ta. So what is the meaning of T? T is nothing but temperature measured at a distance y from the plate surface. Suppose we have to calculate the dTh at this point. So T is nothing but temperature measured at a distance y from the plate surface. We have to measure the temperature at this particular point. At this particular point we have to measure the temperature. That temperature is nothing but capital T, and Ts is nothing but the surface temperature of this plate surface temperature is nothing but Ts, and Ta is nothing but surrounding fluid temperature. If this condition is satisfied, that is T minus Ts is equal to 0.99 into bracket Ts minus Ta, at that condition the distance y from the plate surface is nothing but thermal boundary layer thickness. If we have to putting the values into this equation, temperature T, Ts, Ta, and we got the answer, that is 0.99. At that distance, whatever the thickness present, that thickness is nothing but thermal boundary layer thickness. In last lecture we discussed about the velocity boundary layer thickness. In that what we said, that is thickness up to which velocity of that particular point is 99% of the free stream velocity. At that thickness is nothing but velocity boundary layer thickness. Similarly, we said that if the T minus Ts is equal to 0.99 into bracket Ts minus Ta, if this condition is satisfied, means at that particular distance y from the plate, that distance is nothing but thermal boundary layer thickness. So this is nothing but thermal boundary layer thickness, that is delta Th is nothing but thermal boundary layer thickness. If suppose we have to moving further in the plate, then what will happen? Then temperature of the adjacent surfaces increases, because that surface is continuously moving on the surface. Because of that, what will happen? The temperature of the layer will be increases. Similarly, at the same time, this upper layer's temperature also as more as compared to this second layer. Third layer temperature is more as compared to this third layer. So in this way we got the thermal boundary layer profile. So temperature is changes in this way, and this point is nothing but, at this point this condition will be satisfied. At this point, any point on this curve, at that point this condition will be satisfied, and that curve is nothing but thermal boundary layer. Means what? Inside this thermal boundary layer there is a variation in temperature. And above this layer what will happen? The temperature of that liquid same as this fluid temperature. So this fluid temperature is Ta. So temperature at this above this layer, that temperature is nothing but Ta. That is the same temperature as the fluid temperature. So inside the thermal boundary layer, temperature difference is created. So what is meant by thermal boundary layer thickness? It is defined as the distance y from the plate surface at which T minus Ts is equal to 0.99 into Ts minus Ta. So this condition is, that is Ts is greater than Ta. Temperature of surface is greater than temperature of the surrounding fluid. So this diagram is for if the temperature of the surrounding fluid, is higher, as compared to the flat plate, that is second condition, that is Ta is greater than Ts. So what is the diagram, or what is the profile for that case? That is the same profile as the hydrodynamic or velocity boundary layer. In that case, whatever the profile we got, in that way the same profile will get if the temperature of surrounding fluid is higher as compared to the flat plate temperature. So this is the diagram for if Ta is greater than Ts. So for this, So this is the temperature profile, and in this way we got the curve. So this is nothing but thermal boundary layer thickness, that is delta Th, when the Ta is greater than Ts. So this profile is the same as the velocity boundary layer profile. So whatever the curve we got in the velocity boundary layer, that VBL, that is velocity boundary layer, same as the TBL. When the temperature of surrounding fluid is higher than the surface temperature, So TBL concept is analogous to hydrodynamic boundary layer. The parameters which affect their growth are, however, different. For the velocity boundary layer and for the thermal boundary layer. Parameters are different for the changing their profile, but whereas the velocity profile of hydrodynamic boundary layer depends mainly on fluid viscosity. In velocity profile is created because of the viscosity of the fluid. But what about the TBL? How that thermal boundary layer is created? That boundary layer depends on the first factor, that is fluid viscosity. Second, velocity of the flow, specific heat of the fluid, and thermal conductivity of the fluid. Means what? Velocity boundary layer thickness or velocity boundary layer profile is depends on the mainly fluid viscosity. But what about the thermal boundary layer? Thermal boundary layer depends on the fluid viscosity, then velocity of the flow, then specific heat of the fluid, then thermal conductivity of the fluid. So on these four factors, thermal boundary layer is depends. So the relative magnitude of delta and delta Th. So delta is nothing but velocity boundary layer thickness, and delta T is nothing but thermal boundary layer thickness, are affected by the thermophysical properties of fluid. So this is about the thermal boundary layer. So what is meant by thermal boundary layer thickness? That thermal boundary layer thickness is defined as the distance y from the plate surface at which T minus Ts is equal to 0.99 into bracket Ts minus Ta. If this condition is satisfied, at that time that distance is nothing but thermal boundary layer thickness. So this distance is nothing but thermal boundary layer thickness. So this is about the thermal boundary layer thickness. So thank you very much.